Okay. The class has been recorded. So today I am going to discuss 3 regressions. 3 regression models with regularity condition So number 1, Ries regression. Okay. Number 2, Lasso regression. So least absolute shrinkage. What did I forget the other one? Least absolute shrinkage. Last one is operator. Okay, it will come to my head. Okay, give me time. And number 3, elastic net regression. Okay. Least absolute. Yeah, I'm going to tell that. Least absolute selection. Least absolute. I forgot another S now.
Absolute shrinking.
Shrinkage. See, I don't know. I'm not that old. I told you shrinkage. Now I forgot shrinkage. Least absolute shrinkage selection operator. Okay. These 3 regressions I am going to discuss. Their mathematical derivations will be discussed. All of these things. Okay. So first of all, discuss what is Lagrange multiplier. What is Lagrange multiplier? Okay. So suppose I want to ask you, solve the equation or function to find minimum or maximum. Minimum or maximum of fx equal to, okay, 4x square plus 3x minus 70 equal to 0. Right? Find the minimum or maximum of this equation. So what you will do, you will differentiate this, right? Which is equal to 8x, 3 equal to 0. You plug 0. Okay. And then you find the value x equal to negative 3 over 8. Right? This is first order derivative equal to 0. If you plug, if second order derivative is negative, then you get a maximum. If second order derivative is positive, you got the minimum, right? This is the way. Okay. But if I ask you, find the solution of 3x square 4y cube plus 17 equal to 0. Understand? This function you want to solve, like fx equal to this. You are asked to find the solution of x and y. What is the value of x and y? So this is the equation which has two unknown, right? One equation x square plus 3x square plus 4y cube plus 17, two unknown, right? With the condition that x square plus y square must be equal to 10. Do you understand? So you are asked to solve the values to find the solution of x and y, that the x and y, when you take the x square, when you take the y square, that must be equal to 10. Are you understanding? So this is unconditional function, right? That is unconditional function. Clear? That is unconditional function. There is no restrictions. Now I have written a function which is equal to 3x square plus 4y cube plus 17 equal to 0, or just 3x square plus 4y square plus 17, under the condition that you have to find the value of x and y, so that x and y, x square plus y square, must not exceed 10. Okay? How can you solve this? Are you understanding? If I give you an equation, ask you to solve it, you can solve it either directly, if linear equation, or take the first order derivative, then you can solve it. You can say that that is the maximum or minimum of that function. But now I want you to solve a function, equations that has two arguments, x and y, but the condition is that x square plus y square equal to 10. Understand? More specifically, suppose I want to solve these things. More specifically, like I want to write an example. I want to solve the function f(x, y) equal to x plus y, subject to the constraint, z of x, y equal to x square plus y square equal to 1. Do you understand? I want to find the functional value that x square plus y square must be equal to 1. So can I write like this way? X square plus y square minus 1 equal to 0. Can I write like this? Okay. Now, if I write like this is like that. That is equal to 0, right? Now I can write that Lagrange. What does Lagrange means? Lagrange means here is the unknown x, unknown y. This is L, stands for Lagrange, and then lambda. And then he said you put the f(x, y) plus lambda times. You can put here your function. You can write here x square plus y square minus 1. You understand these things? So this part equal to what? This part equal to 0, right? That part equal to 0, right? So what he said, my purpose is to get x and y. What will be the value of x and y under this? That is the main question. what is the value of x and y, so that I can find, I plug in there under that condition, x square and y square. Now, under that, if you differentiate these things, L with respect to x, then here is just 1, you will get 1 in here, because this is equal to what? That is written as x plus y plus lambda x square plus y square minus 1. Now, if you differentiate this with respect to x, there is a 1 plus lambda 2x, right? 1 plus lambda 2x. Are you understanding? Are you understanding this? Del lambda del of y, if we differentiate it, 1 plus lambda 2 of y, and then del lambda, if I do this, then it will be just x square plus y square minus 1. Do you agree with that?
I have a question.
Yes.
For the differentiation of the first one, how did you get 1 plus lambda 2x?
How did I get this one, right?
Yes.
So if you differentiate this, d, so suppose f x equal to x, right? So differentiation of f of x dx equal to 1, right?
Yes. Okay. Okay.
Now, this is coming as a 1, and that is coming as a 2, okay?
Okay. Yes, thank you.
So now if I plug in here 0, first order derivative equal to 0, like this, if I plug all of this, then what I am getting in here, from there, I am getting x equal to minus 1 over 2 lambda, y equal to minus 1 over 2 lambda. So that means x equal to y equal to minus 1 over 2 lambda. Okay? Clear, right? Are you getting it? This idea will be used in like the Rees and Lasso regression. Okay? So after doing this, online people, are you okay? Are you understanding? Now, these values, if x and y's values, if I want to put x and y's values in here, then what I am getting in here, 1 over 4 lambda square plus 1 over 4 lambda square minus 1 equal to 0. Okay? Are you understanding? Right? So from there, what we are getting now? We are getting from there, now we are getting 2 over 4 lambda square equal to 1, and then 1 over 2 lambda square equal to 1, and then if you change it, lambda equal to 1 over like this plus minus. You understand? Okay. Now if you plug the lambda's value in there, lambda has the 2 values, right? If you plug these values in there, one is plus value, one is minus value, you will come up with the results. And finally, if you plug this value, you can now estimate the function. So what will you have? You originally have these things. If you plug in there, originally you have with the differentiations, you have these things: d, l, dx, dl, dy, dl, d lambda. When you do these and that, and you had these values, 1 plus 2 lambda x, 1 plus 2 lambda y, and then you had x square plus y square minus 1. Okay. This is your all first order derivative point. Now, if you plug the values in there, you will get something like this. Because there is now 2 lambda, sometimes you plug positive lambda, sometimes you plug negative lambda, then it will be 2 over 2. You can check these things at home. 2 and then minus 1 over like this. This is a one set. Another set, if you plug negative value, 2 and then 2 and then 1 over 2. Okay. So if you take a look at that, this is what you are getting the first derivatives values when you plug the lambdas. And finally, you can find the constant maximum value and minimum value, all of these things. Now, the purpose is to show you that, let's see how I added this. What Lagrange did, Lagrange just with the original function, he added these things. That is how he became famous. Understand? So, before starting this class, if I ask you, come, solve this problem. Anyone from you, before discussing these things, if I say, I want to solve this equation, x, comma, y, comma, z, I have a function 3x cubed, 4x square, and 9z square. I want to find these things. Okay? So there are 3 unknown, right? X, Y, Z. X, Y, 3 unknown. Y, right? Sorry. And then at the very beginning of the class, if I come and say to solve this with the condition, 3x plus 3y plus 3z equal to 10. Okay? So what he did, he just used a lambda in there and plug it with this function and differentiate this. He got the first order equation, something it is called. Okay? And then find the value of x, y, z and lambda, all of these things together, they plug and then they solve the equation. Clear, right? So you understand what is Lagrange multiplier is.